All right, so good morning, everyone. Thanks again for joining us. My name is Sarah with 3C Ren, and I've started recording this course, which will be posted on our on-demand page. Today, we have Jennifer Rennick and Grant Murphy with us from Imbalance Green Consulting to talk about how to best implement the energy code to comply with for your non-residential projects. Before we get going, I just have a few slides to run through. We just ask that everyone make sure that you're on mute throughout the duration of the course. And if you'd like to verbally participate, like Jennifer said, please raise your hand and we'll call on you to unmute yourself. We also have Grant and myself overseeing the chat box. So if you have any questions, please feel free to add them in there as well. So just a few words about who we are. We're the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. And 3C Ren currently offers 3 programs. So the first of which is our Energy Code Connect program, which this course is brought to you today from. And this program serves building professionals by offering trainings and support to make the energy code easier to follow. Within the Energy Code Connect program, we have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24, Part 6, and Part 11 related questions. And that's both for residential and non-residential projects. Grant and Jennifer are 2 of our Energy Code coaches. And then we have our next program, which is our Building Performance Training program. If you go to the next slide, perfect. And this program serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles and high performance buildings. And then our third program is our Home Energy Savings Program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through both incentives and rebates. And with that, I'll pass things over to Jennifer.
Hi, welcome everyone. Today we are looking at kind of the 2022 Energy Code. And in this particular series, we're looking at things that we've noticed as code coaches and also as consultants, kind of the areas that we get questions. A lot of the folks who come to us are architects, so some of the slide deck here is going to maybe look a little more specifically at some of the issues that come up for architects. So I understand that we have a small group of folks. Not everyone's architect, so we're happy to make this presentation a bit more of a dialogue so that it works for everybody. So ask some questions as we go. And today we're going to take a look at the non-residential standards. There are learning objectives for this. So if you are an architect, you could get AIA Learning Unit credits. And if you're part of the ICC, we also have credits for that. Today, we're going to take a look at the 2022 Energy Code, kind of a big picture overview. We're going to take a look at some terms that are commonly used in Title 24. We'll review some of the mandatory measures, and in new construction, the prescriptive and performance measures that seem to be coming up to the forefront in what we've been seeing and doing. That's where the bulk of the presentation is going to lie. And then I have just a few slides on additions and alterations just to kind of highlight some of the changes from the old code to this code. And those measures, there's so much in the additions and alterations section of the code that really you could spend hours on it. So I'm just going to highlight a handful of things and just to make folks aware of it if they're not used to reading the code book themselves, the energy part of the code book, that is. Well, kind of most folks probably realize this already, but the California Energy Commission has their codes and standards for the energy code, and it's updated every 3 years. And that process includes engagement with the public and industry experts, stakeholders, et cetera. And if you're not aware, that process has been going on now for the 2025 energy code update. And coming up next year, we'll actually start talking about the new code that's coming up. And this is going to give you a highlight of where we are now with the 2022 code. And this particular code for 2022, it really was encouraging heat pump technology for space and water heating. It established that electric ready requirements for the single family and multifamily projects. It expanded the PV systems and battery storage standards for non-res. So we're going to spend a little bit of time on that because we see a lot of questions keep coming up about that. And it strengthened ventilation standards for outside air, namely because a lot of projects, both the residential and the non-res, are going with heat pump systems that don't necessarily bring in outside air. So DOAS and heat recovery, DOAS being dedicated outside air systems, are now becoming more and more popular. And all of this is part of California's big picture goal to reduce greenhouse gas emissions and reduce energy. Real touch on this real briefly. The code now is organized subchapters 1 and 2, kind of deals with all the occupancies, the main overscope. And then the energy code is broken into 3 big sections. And the single family residence deals kind of with chapter 7, 8, 9. And now multifamily has its own sections, 10, 11, 12. And then everything else that's not those, so it's not residential, is the non-res. It includes hotel motel as well. And those are dealing with chapters 3, 4, 5, and 6. And chapter 6 being its own section with additions, alterations. And today we're going to focus on kind of that part of the energy code. So just for the non-residential, some of the high-level changes here is that there's been some envelope and fenestration updates from the previous code. There's been updates on the heating and cooling systems, fans, outside air ventilation, which we talked about, lighting, indoor and outdoor. We'll talk a little bit on some of the lighting controls. There's some new items there under covered processes, and there's a big section here for photovoltaic and battery systems. And just as a reminder, the way now this code is organized is when you're working on your hotel motel projects, some of that code language is actually going to reference for the guest rooms, reference to the multifamily portion of the code. So there's a little bit of back and forth, but mostly everything here in the non-res is going to be similar to how it was, with just a little bit of the high-rise residential in there and a little bit of the hotel motel referencing you back over to the multifamily. 3 terms, just to review, because you'll hear me say these. When I say mandatory requirements, I'm talking about, or mandatory measures, those are the energy efficiency measures that are applicable to all the projects. And then the prescriptive component package, the mandatory measures are still applicable, but now we're going to follow the recipe card, essentially. We're going to follow a checklist. And when it comes to the prescriptive package, it's kind of an all or nothing. You do all the components that are in the prescriptive package. Otherwise, you do the performance method. And in our work, we do a lot of work with the performance method, although I'm noticing more and more mechanical engineers are using the prescriptive pathway for certain aspects, well, especially lighting, but mechanical now for hot water. And we'll touch on that when we get to that section. I mention this now as we go through this, the prescriptive component package elements, because those elements are many times the baseline that's used in the performance or energy modeling approach. And the advantage, of course, of performance method or energy modeling approach is you can do trade-offs. So if you're not able to meet the standard in one aspect, you could do something that's better than the baseline or standard and get credit for it. And then the average energy use, if it meets those requirements, you're good to go in terms of showing code compliance. So a performance metric, computer modeling, it's going to go take a look at regulated energy. And regulated energy is space heating and cooling, ventilation for outside air, water heating, indoor lighting, solar PV, battery storage, covered process loads. There are, of course, outdoor lighting is also regulated, but it's those aspects that are highlighted in the green box that can be used a lot of times to trade off other features. And the compliant software has been set up to show compliance based on climate zone. And it also is including heat pumps as some of the baseline features in certain situations. One thing, by now, if most of you are practicing in engineering architecture, you've seen that now the Title 24 computer reports have two metrics, just as a review. One of the metrics is source energy, and really that's being used as a proxy for carbon. And part of this is California's goals to reduce greenhouse gas emissions. And one way to measure it is to use a kind of a proxy for carbon or CO2 equivalent is how they're kind of, phrasing it. And so that's one metric that needs to be passed. And then the other metrics you're probably familiar with. And if you're new to this, it's called TDV, or time-dependent valuation energy budget. And that's typically what we were using under the prior code cycles. And TDV, we look at it both for the energy efficiency of the building itself, and we're looking at it for the energy efficiency of the building plus the PV and battery systems. And this kind of energy includes the amount of energy it takes to get electricity to the building, for example, through the transmission of electric lines themselves. And that varies with the time of day and the source of the energy and how that electricity is created on the grid. So example output would look like this, where you would see an efficiency, TDV or time-dependent efficiency, and you'd have your standard design, your proposed design, and if the project passes, it'll say compliance mark pass. And then the TVD total includes the PVs and battery, and you get a pass. And then the source energy, which is the proxy for carbon, if your proposed design does better than standard design, it'll show as a pass. And then the other thing that computer software is going to calculate for you, it can be very handy. We get a lot of questions on this, is that it'll size and let you know based on your occupancy types what that standard design for the PV capacity is in kilowatt DC. So it's a nominal sizing. and the battery system capacity in both kilowatt hours and kW for power. Okay, any questions or comments before we kind of move on to some of these mandatory measures and review? Okay. Anything you want to add, Grant?
No, George had one, but we can touch on it at the end of the presentation. I got back to him quickly, so you're free to keep going.
Okay. And also, I didn't get a chance to scan the chat. Are most people familiar with the energy code? Could you tell? Or are we, because I can keep it more basic or go into more detail.
We have a plans examiner, 2 plans examiners, a student assistant for the CEC, George, a PE, who's attended a lot of these. So yeah,
okay.
I think this is good content.
Okay. All right. So one of the things that we have now in the mandatory measures over the years, in each code cycle, it seems that the mandatory measures become more robust in the sense that a lot of times something will be an optional way you can show compliance under the performance method. And then as the next code cycle comes into play, some of those optional things will become either a mandatory measure or be baked into the prescriptive componentry. And so, or sometimes just new energy efficient standards. The items themselves are more energy efficient. And so that comes into these mandatory measures. So there's increased HVAC efficiencies now for a number of the cooling systems, cooling towers, furnaces, and boilers. And there's new tables for dedicated outdoor air systems, or DOAS, for the computer room units, and a lot more to do with computer rooms or server rooms. And there's new standards or tables for what we expect to see for heat pumps and heat recovery chillers. And all that can be found in section 110 through 110.12. When it comes to the glazing and fenestration, there was a minor update, and basically in the past codes, we were able to use a formula to calculate our kind of glazing components and the energy performance for our U factor, solar heat gain coefficient, etc. And now that's been reduced to using that formulaic process just for skylights less than 200 square feet. And that formula is no longer valid for vertical fenestration, which we usually call windows. So the main takeaway here is that nearly all the projects will be using an NFRC rated window or rated unit throughout the project. And how that translates into code implementation is that part of the acceptance testing, once that building is built and you have your NRCC form, or AKA your Title 24, air quotes, Title 24 report, a piece of that is the envelope measures. And now there are many features that go into that, but fenestration specifically then has a NRCI and an NRCA. So installation needs to be verified, and then an acceptance form needs to be verified. And that is where a person takes a look at what was in the project and takes a look at the labels on the glazing and make sure they're a match, and specifically looking at U factor and solar heat gain coefficient and visible light transmission. And on this particular one, anybody can perform the test as long as they're meeting the qualifications for being able to practice the business in California in that sense. So reason we're seeing it is I've been asked a few times to come out, can I do this and look at it? As an architect, the architect can do it, and you can have other folks do it. But this forms really, it's to try to have a double check on those windows. And the reason I kind of mention it is because windows can make a huge difference in occupant comfort and the overall energy use. And so it really, I think, pays to have a double look on the window and see that that is installed properly. And that's what these forms are about. The next thing we've kind of noticed that folks have had questions on, or has kind of come back around, is the requirement for duct leakage testing in non-residential projects. A lot of us are probably used to hearing about duct leakage testing and being a HERS measure for residential occupancies. But new to the code this year is that, called out specifically in the energy code, is that the systems that are single zone, sorry, I almost said variable, but now I stopped myself. So sorry, I stalled out. Constant volume, single zone space conditioning systems. Okay, serving less than 5,000 square feet of conditioned floor area. And if you're having more than 25% of the ducts in unconditioned space or outdoors, although we don't recommend that it's outdoors, but if it is in unconditioned space, at least that you would have a HERS verifier come out and a HERS rater come out and verify that there's 6% duct leakage. And there are some exceptions to it, like healthcare facilities. And so this is an example of where duct leakage was previously a prescriptive component under the old code cycle, but now it's a mandatory measure. And where the questions, what we've noticed now is in the code language, it says HERS rater. And so you usually think of a person who does a lot of residential work, but for small commercial projects, this could be the way to go. And they would use an NRCV form, MEC for H for HERS and V for verification. And they would bring their calibrated fan and flow meter to the site, connected to the duct, similar to this example in the picture. They cover up all the registers so that they can get a good pressurization test, and they would take care of your verification forms for part of permitting. And this gets turned into the team at the authority having jurisdiction, turn into those folks. And once they do that, then this form would be watermarked with the data registry. However, with non-residential work, what you might see is that you could also use an NRCA MEC for A form, and this one is acceptance testing was established specifically with acceptance test technician and ATT in mind. And what we've noticed in our area, and this might be, some discussion if any of you are familiar with this, is that we have seen that some builders were having a hard time getting a hold of ATTs and wondering if they could use the HERS rater. And you can use a HERS rater even with this form, as long as, and I highlighted it in yellow for you, who can perform the test, as long as it's at the discretion of the authority having jurisdiction, and they can do that. And they talk about sampling, and sampling's typically done for large, multi-unit projects. But this has come up, and so this could be a way to deal with it. Otherwise, most of these tests, really, even though it says HERS in the code, they were kind of set up for acceptance testing technicians to do this work.
Yeah, the inside baseball on that was that for the past couple of years, there wasn't enough license acceptance test technicians in the state. So just recently, as a whole, California exceeded the amount of those licensed individuals, where now they are requiring that it is a licensed ATTP. However, a lot of jurisdictions, like Jennifer said, we still don't have enough of those individuals. So even though California says it has to be one of those, people are still deciding to allow qualified HERS raters to do so.
And then if you crack open that code book and read it for those single zone constant volume systems, they say HERS, right there too. So it adds a little confusion, I think. So
definitely.
Yeah. And then kind of along with some of the changes that came into the code, and then this change has to do with your minimum ventilation rates. And by ventilation, I mean outside air ventilation. And there's been some updates on that as, if you're doing your performance modeling, you might look and see that, okay, I've noticed I need more outside air. But really, for your mechanical engineers that are designing the system, okay, they've got to look it up and figure out exactly the occupancy and then design accordingly. So it's an increase, but I don't see that it's going to affect anyone's workflow much. But what maybe is different is that now we're going to have testing, and specifically we're going to test those variable air volume systems now that they're capable of maintaining the measured outside air rates within 10% of the design minimum, and all the mechanical ventilation and space conditioning systems are tested and confirmed that they operate within 10% designed minimum outside air rate. And so this is new from the last code cycle. So maybe you folks that are in practice have seen this a bit. And here for the VAVs, for the variable air volume systems, they do require an acceptance test technician. It doesn't give you the HERS option. This one really is to be done by an ATT, and they have their acceptance forms, and then there's a great form that goes with it that kind of lays out some of the instructions. So if you need more information on that and what it entails, by the way, these forms, they come from the California Energy Commission website under their if you just Google like CEC 2022 code forms, it'll link you to this part of it where you can then take a look at the website and find all these forms. Now you notice that the forms I'm showing you have this watermark on it that's kind of grayed out, and it just says that this compliance has to be watermarked by an acceptance test provider. So you have your acceptance test technician certification provider that the ATT works for, or it could be one and the same. And then similar to a HERS registry, they would take the form, they upload them, and then they're able to print the forms that have the appropriate watermark on that. So California wants to start to track and look at the data and have that data registry for these and have these things watermarked. Also, to know that the ATT is being trained to do this kind of work. Okay, anything you want to add on those? And then I'm going to hit on a little bit on the lighting controls.
No, that's great.
So, so a couple of the changes for lighting, the lighting is maybe more energy efficient in the sense that we're looking at using a less wattage per square foot in a building, because we can do that with LED lighting. And that we've seen that for years now. And it's almost one of those things where we were seeing more LED lighting and lower lighting loads in commercial projects. And then the code was catching up with it more. So some of in our performance modeling, some of those credits went away on this code cycle. But now it seems like, okay, this code cycle is matching a little bit more about where the industry was. And one kind of tweak on this is if you're doing lighting demand response controls, instead of basing that on a 10,000 square foot threshold, which coincided with projects that also could need commissioning, the lighting system, a total installed lighting power is now 4,000 watts, which in my experience so far, 4,000 watts, 10,000 square feet, they're pretty close to each other. When we think that a lot of our office buildings that we've worked on, a lot of the electrical engineers have ended up designing those office spaces around a 0.4 watts per square foot LPD anyway. So, but that's just to fine tune it, that it's not really going to penalize or like really subject to the buildings based on their square footage. It makes more sense to base it on watts, because that is what the demand response is all about. It's all about reducing energy, about reducing the wattage. And the demand response system, if they're required to have it for the lighting, then they're also going to be required to have it for some of the receptacles. And then, of course, exception for health and life and safety. Okay, and then that demand response from the utility would reduce the lighting power by 15% or greater. And the indoor lighting controls, there's just been some update on the manual area controls and shut-off controls, a new requirement for offices greater than 250 square feet. And the automatic daylighting controls are now mandatory in the secondary daylit zones. And there's been a little bit of language that specifies that scene controllers can be used if at least one scene turns on the general lighting only, and then the control provides a means to manually turn off all the other lighting. And what I've noticed in the last few trade shows too in the last few years is that a number of the lighting companies are coming out with all kinds of sophisticated controls. So it should be fairly straightforward to meet the energy code. With the controlled environmental horticulture under process loads, there's some mandatory measures that are now in place. And for a little while, I don't know about you guys, but for a little while, we were seeing a lot of controlled environmental horticulture that was specifically set up for cannabis growing. And Grant, I don't think that's been as prevalent lately. We haven't had too many of those projects, have we? After that wave of them.
Yeah, not as many as there were a couple years ago, and a lot of them are in exterior, like hoop house growing situations. So they're not doing the conditioned space full warehouse facilities as much, at least in our area that I've seen.
Yeah, yeah. So I wanted to just mention it because we were seeing a bunch of this for a while. And so if you are doing this kind of project for your clients, it's really what we found out, it seems to be really niche now. And so if it is a new thing that's come up for you, you should know that there's a number of mandatory measures that go into it, and that there's a resource available too if you're just getting into it, where Energy Code ACE has put out a fact sheet now for this specifically, and it's multi-pages, and it tries to pull all the parts of the code and put it into one multi-page document. At least it's sort of in one place you could kind of look at as a whole, and then from there go back and research each specific code section, but they index where that came from. So I think that could be a great resource if you end up with one of those projects. I've noticed it's become really niche, like the same folks are kind of working on them in multiple places, rather than a lot of us dabbling in a little bit of that controlled horticulture environment now. But in contrast to that, almost every project we've been working on, there's a chance to have computer rooms or server rooms. And if that computer room, or you might hear it called a server room, has an electronic equipment load of 20 watts per square foot of that connected power density, then it qualifies under the energy code as being, air quote, computer room. And there are certain requirements now that go with having that space. And so here's an example of a project that we were working on, where they had a server room where each of these cabinets, it's under construction in this picture, each of these cabinets are going to have all of their server equipment. And there's now HVAC efficiencies that specifically address like the reheat controls and prevent reheating and simultaneous heating. And that's now just a mandatory measure. And so in this example, they just solved it by using variable speed fan and no reheat on the system. And then this duct system connects to a roof mounted heat pump for it. There's been some updates now for commissioning and when commissioning is required. And even though a lot of discussion about commissioning falls under the Cal Green Part 11 of Title 24 code section, the commissioning requirements for that are listed in the energy code pretty much read just like they did in the previous code cycles. However, you might look at that and not realize that there's been changes to the commissioning, because they're now listed under the Part 11 under Cal Green. And, new construction that includes the initial interiors build out of shell construction. That's a question that comes up for us a lot. And under those non-residential occupancies, we get this question a lot. Does it include the non-res portions of hotel, motel, and high-rise multifamily? Yes, it can include that. Grant, do you have you might jump in on the commissioning side of it. But
The only item that I have big picture for commissioning is just that the follow through for commissioning is requesting, because the commissioning agent primarily works for the owner, is for jurisdictions to request to see the commissioning plan and the commissioning report. When those aren't requested by the building department, that follow through doesn't happen all the time. So to see that this requirement is happening and is being implemented, the emphasis is really on at the end of project to make sure that those two items are actually completed and received by the building authority.
Yeah, good point. So the things about commissioning, it's listed in section 120.8. And when you look to see, well, what has to be commissioned, it's basically everything that uses energy. So it is the HVAC mechanical system, including the outside air ventilation, the controls for it, anything that the economizers and heat recovery is part of it, your commercial kitchen exhaust systems, and the lighting, all your lighting controls. And Cal Green additionally includes the renewable energy, the irrigation systems, and the water reuse systems, even though that isn't in the listed in part 6 of the energy code. It's triggered in part 11 of the energy code. So there's some overlap, a kind of cross-reference. So if your project is greater than 10,000 square feet and commissioning is being triggered, you'll want to look at both sections. And then if you know, kind of the architect's perspective and also the plan reviewer's perspective, the commissioning documentation is part of the air quotes, so like Title 24, the Part 6, and there is the NRC CRX form for commissioning. And under the old code, it was a form fillable form, and now a lot of these forms are moved over to Energy Code ACE website. So on behalf of the California Energy Commission, they've created online interviews and a way to fill in these forms. And then through that website, your form can be produced. So if you're new to this in general, you'll want to set up a user interface with Energy Code ACE, and you'll get a copy of the slide deck, and it'll be in there, and then you can set that up for your practice to fill these forms out. It's also where you will find a lot of the prescriptive forms for mechanical, hot water, and envelope, as well as the commissioning for the non-res projects. And then when you go to the Energy Code ACE, you can click the Complete Certificate of Compliance section, and then it'll take you to those interviews. Okay, so that kind of wraps up the mandatory measures. Then we're going to dive into some of the top items that I've been seeing under the new construction, under prescription, the prescriptive and performance method. But mostly we're looking at prescriptive in the sense that it sets up the baseline for the performance modeling. And so this chapter, this section is basically organized into the general. You've got your performance approach and the prescriptive approach. But really, after that, then it's broken out into those categories of building envelope, your space conditioning, water heating, indoor, outdoor lighting and signs, all your covered processes, and then your photovoltaic and battery storage systems. So there's been some updates on the roofing products, solar reflectance. Again, this more for the architects to take note of, because when it comes time to speccing out these materials, you'll want you're going to need to meet these requirements. And it's important to note when you go into this part of the energy code, there are separate sections for the non-residential buildings, your guest rooms for hotel motel, and the relocatable public schools. Like if you have to understand that if you're working on one of these other two things, don't grab everything that's just the non-res in general, which is set up for everything that's not hotel motel and the public school relocatable buildings. And then the high-rise residential altogether has been moved into a different section. So there's been some changes on these to reflect the climate zone, and you'll get a copy of the slide there. And for the envelope, there's been some updates to the tables that we look at for prescriptive measures. And this is just an example of the non-res, not the hotel, motel, and school, but just everything else non-res. And I gave a copy of the table that shows what the previous code had and then the changes. And so for metal framed walls, for example, there's a lower minimum U factor requirement. So that has changed. There's a higher minimum requirement now for the age solar reflectance on the roofs, which we're just taking a look at, and also for thermal emittance. And then now for the first time, as part of a prescriptive requirement, there's the air barrier now being required in every climate zone. And for the fun of it, I'm going to just take a closer look at the metal frame building and the mass heavy walls, or sorry, yeah, metal framed walls, not building, but metal framed walls and the mass heavy walls. Because what we're seeing is that now with this code update, is a lot of the projects that we were getting that were office spaces in our Tri-County area, they were wanting to construct these walls with no exterior insulation. And it's possible, depending on your climate zone, but you'll need to use the computer performance method. If you were going to use the prescriptive method, you need to comply with the U factors of 0.06, 0.071, and 0.055, which is completely dependent on the wall assembly and your climate zone, like how your project's going to perform, or whether it's going to meet the prescriptive requirement. So just to give you an example, for climate zone 3, which is kind of the more mild climate zone, you could use a 2x4 metal stud wall and have an R13 bad in the cavity with an R10 exterior, and you would have a U factor 0.068. That would be better than the 0.071. So that works for climate zone 3. If you increase that exterior insulation on that wall, now you'd have to R12. Now you'd have a wall assembly that would work for climate zone 1, 3, 6, and 7. And if you increase that exterior insulation to R14, we'd now have a wall assembly that could be used in all the climate zones. And what we're noticing is that the thickness for the exterior insulation in all of these scenarios is a bit more than what a lot of the architects and builders in our area are used to dealing with. And so really what they're asking is, well, what's the minimum mandatory measure I could do? And then can we make up the rest in the fenestration, the lighting, and the heating and cooling systems? And yeah, sometimes you can, and sometimes you can't. So it makes it a little tricky. The U factor for the code minimum is a 151 U factor, which you could do by using an R8 continuous insulation, but really you're trying to get away from that. You could also just use a 1/2 inch of continuous rigid, like an R2, which wouldn't impact the project too much. Okay, and so the reference appendices is where you can find that information, but more and more we're seeing projects like this, which is a project in Santa Barbara, actually, even though, and this particular wall assembly would work for climate zones 1, 3, 6, and 7. And then for those other climate zones, we'd increase that continuous insulation to an R14. But this is showing R12, rock wool insulation. And so they created a wall assembly where they used a self-adhering air barrier wrap on sheathing over the studs. And then to the exterior of that, they did the R12 continuous rock wool. And then they created a rain screen where in some cases, this one's got you see a lot of added horizontal components because they're going to use like a special clay tile for the rain screen. But just beyond the picture, there's a lighter weight rain screen product that was set up for all their stucco. And then what you can't see in this picture is the actual 2x studs with the cavity filled insulation. But this is an example now of what we're seeing. And so it's just impacting the detailing for the architects. But then now you can use the metal framed building, no problem. And then the other thing we're seeing in place is projects that are going with an 8-inch, like normal weight CMU solid grout wall. And it meets the requirements of being heavy mass when it's the normal weight CMU. And with the solid grout, the code, it didn't change so much in terms of necessarily requiring exterior insulation prescriptively. But if you were to use an R5 continuous insulation, it would cover all the climate zones. And then for climate zones 2 through 5 and 10, you could just add a layer of sheetrock, for example, with or without furring strips, and that would meet that U factor requirement. And then for climate zone 6 through 9, so like down in Santa Barbara, Ventura, you can just use the CMU without doing any exterior insulation. But in this particular project, they used an R10 continuous exterior insulation. This was in one of the colder climates. But the reason they went with R10 is once we calced it and they had to have they needed the R5 for better performance. That was like, well, they went with the R10 to get even better performance because then they traded off other things under the computer method. And this is just an example of what that might look like. And they went ahead and put that continuous rigid insulation in between the CMU and their furred out, or, but was furred out with steel stud wall. So they could leave the cavity completely open for all of their electrical work. For the fenestration, this is just kind of a reminder that the type of fenestration, whether it's a fixed window or curtain wall storefront or operable, those are determined by your climate zone, which is new to the code. And so climate zone 9 and 11 through 15 ended up with new values and for fixed windows, and then for curtain walls or storefronts, climate zone 1 and 7 ended up with some new values. And what that translates into is when you do the performance method, maybe you would have gotten a little bit more credit for those windows, and now you wouldn't in those particular climate zones. So for space conditioning systems, there's been some updates for these single zone systems, the split systems for school buildings, retail, grocery spaces, and based on the function of, or the occupancy function, then it was determined whether or not the baseline would be a heat pump. And so the more mild climates where it made sense, the baseline is a heat pump. And then for the colder or more extreme climates like climate zone 1 and 16, in a lot of cases, it might be like for school buildings, a dual fuel heat pump, meaning it can operate natural gas furnace can kick in when the heat pump perhaps reaches a time and temperature where it's out of the range, where it's just not as efficient or cost effective. And so the main takeaway from this is that the California Energy Commission was looking at what system made the most sense to be cost effective for people and the state, as well as improve energy efficiency. And there are some new fan power budgets. Again, this gets a little bit more nuanced. I want to mention it because California, with the commission, they've really gone through and they said, okay, it doesn't make sense anymore just to have this fan power for everything. It's more nuanced than that. And we need to look at, is this air handling unit serving spaces more than 6 floors away, for example? Or is there a MERV 13 or higher, MERV 16 filter on it, or something more than that? So with each of these situations, and whether it's single zone or multi-zone and VAV, then, and the size, it's going to give you these different fan power budgets. In practice, what we've seen is that if the engineers are taking these and complying prescriptively, well, then they're in here making sure all this is met. And if you're using the Energy Code ACE prescriptive forms, it will walk you through a dialogue, ask you these questions, and then it's going to tell you what that fan power budget needs to be. And then in the performance method, the computer programming has that kind of baked in as well. And there's just a broadening application for economizers, and the economizers being applicable to lower capacity units now. And there are some trade-offs available. But kind of the main takeaways on this for us, what we've seen in practice, is that now a lot of projects are going with DOAS systems, so dedicated outside air systems with and without heat recovery. And that was something that hadn't been seen as much in the previous code cycles. And so what we're seeing is that for small commercial and residential, but the smaller commercial projects, they could have a dedicated outside air system that has small 3-inch diameter ductwork running everywhere. It doesn't have to be large ductwork to bring in the outside air. And also as a result, just this entire section of the code, 140.4, has been rewritten to really address a lot of what we're seeing now with dedicated outside air systems. Grant, anything you want to kind of chime in on this, because you're doing a lot of more of the kind of working through this with clients and in the Code Coach as well through Code Coach questions.
I've been doing a lot of it for residential. The commercial side, the DOAS, ERVH, or V options. Mechanical engineers are pretty familiar with it, so it's just finding good systems that work well with those VRF systems that most of these larger commercial projects are using. But yeah, in the residential sector, it's here, and it's going to be even more prevalent as code continues to update.
Right. And then on the smaller scale, multifamily, and on the residential, but mostly we're seeing a small commercial multifamily, we're seeing a type of heat recovery ventilation system that's really a box that you can put in a closet, and you've got filters that you can access, and the small ducts, relatively small ducts running throughout the space. And the big takeaway on this is it's really meant to eliminate energy waste by having a system that provides the space heating and space cooling as one system, and then another system that's bringing in the fresh outside air that meets the ventilation requirements. And so for the code, to give you an idea, and again, this maybe is more applicable to the mechanical engineers, is that there are now kind of prescriptive measures talking about the energy recovery requirements by climate zone and by the percent outside air. And so sure, you can look it up by table. I think it's great because it kind of gives us a window into what is going on with how these measures are being set up. But a lot of the mechanical engineers and a lot of the folks we're working with, they're putting this into the computer program, letting it crunch, and we're getting an answer that says, yep, it passes or it doesn't pass. I'm not going to pretend to be the engineer on this. But this gives you an idea of what those values are now, and those are new. And then a lot of the bigger systems we're seeing, they'll just have a large, air handler that has a heat recovery flywheel that is going to bring in the outside air to a system that has a lot of ducts. And now for these systems specifically, there's requirements about their enthalpy recovery ratio being at least 50% for both heating and cooling, for example, and the sensible energy recovery ratio of at least 60%. And then certain things we need to know on bypass controls, and there are exceptions, but we're just seeing some of the larger commercial projects have pieces of equipment like this on the roof to bring in that outside air. So those sections were rewritten. When it comes to water, that's another thing that we've seen difference in the changes as heat pumps become more popular and the energy efficiency has improved and the market in them is increasing. And so we're seeing now commercial and the hospitality projects going with heat pump water heaters. You could still use gas. You could still use natural gas, but for in a lot of situations, for a lot of climate zones, if you do the performance method, you're going to be compared to the efficiency of a heat pump water heater. And this is from a commercial project that we worked on, the office building in San Luis Obispo. And they went with an A.O. Smith heat pump water heater for that office building. So again, if you're not familiar with these, they're a little taller than standard gas tanks. The heat pump is on the top of the tank. The tank is down below. There's a small amount of refrigerant, all self-contained within the top portion of that tank. And each of these, unless they're ducted, typically needs 750 to 1,000 cubic feet of volume in the space. And it does take the air, extract the heat out of the air, and as a result, it produces dehumidified cold air. So it's dehumidified. So as that heat pump is operating, it's condensing the moisture out of the air, and that does need to be drained out of the heat pump appliance and taken out to like a floor drain, which is shown in this example, or into another drainage system. It does produce water. That's the one thing I think architects kind of keep to be aware of, or the mechanical engineers be aware of. Now, for your hotel motel projects, they're going to follow. This is where I'm saying they actually reference the multifamily code. So section 170.2 D2. So you'll go to the multifamily with the hotel motel, and with our central systems, you can still use gas boilers. And this one, this picture, this is from a project we were working on that, although it's technically not hotel motel, it is senior living. A system would be the same, and it's the same idea for, it could have been for a large hospitality system where it meets the 90% efficiency for those projects. And with this, there is supposed to be a certain solar savings fraction, meaning solar thermal, that goes with the gas. But if you're not going to do the solar thermal system, then, and you want to use the natural gas, then you're pretty much looking at going with the performance method, because that way you can trade off that solar thermal system requirement and use other things. So that's probably why we're seeing the performance method when they go with the natural gas systems. Otherwise, for those central systems, you can use a heat pump. And then if you do, we are seeing one of the projects I worked on recently went with an A.O. Smith commercial, their small commercial water heat pump, and they met the prescriptive requirements. They did have to hedge their bet because some of those heat pumps don't perform well in too hot of temperature or too cold a temperature. So they put them in a quasi open room. It was protected from the outdoors, but still had louvers that could be open when the temperature outside was the ideal temperature and bring in air. And then they also had a backup system to make sure that that room never got too cold or too hot. So in the end, they appeared to have met the requirements prescriptively. I don't know if that particular unit saved a lot of energy, but the photo down below at the bottom, A.O. Smith has now recently come out with their heat pumps that could be used individually or sistered together, be plumbed in parallel or series. And it's got their new refrigerant in it that meets the global warming potential. And this thing is meeting all of these temperature requirements. So the point being that this is a technology that's changing rapidly. And you can follow those prescriptive and you can follow those forms. Here's a couple of examples where a roof-mounted system where the Sanco 2 was plumbed to tanks, and then it went into the central system. And then here was a system used for a commercial kitchen that served a lot of folks as part of this multifamily project. So even though these are multifamily examples, the systems are the same. They could be, pared down or expanded as needed for your commercial project or your hotel motel project. And they all have their heat pump, holding tank, and a swing tank or a temperature loop tank that meets those prescriptive requirements. Okay, when it comes to the PVs, there's some equations you can follow. It's not super complicated, but I just want to point out that you are going to look at your use type and then your climate zone. And, oh, excuse me, yes, climate zone. And that's going to give you your multiplying factor. So you're going to either do that to calculate your PV system size, or you're going to look at the available solar roof area and multiply that times 14 watts per square foot. And for mixed use buildings, you would use the occupancy that makes sense for what you're doing, you know, for that portion of the building, and then add it together. So those requirements are additive. There's been some clarification now from the CEC about the solar access roof area, and still it's defined by a roof area that has 70% of the time access solar sun shining on the roof. There are professionals that you can contract with that can help you calculate that. They'll take a drone, they'll fly that drone up over your building and then help you understand your solar access. But the clarification has really come in to say that if there are other building codes that require you to keep those areas clear, those areas don't go into that calculation. So it's just everything that can be free and clear to hold the PV panels, including covered walkways, including covered parking, anything that has a roof that's structurally stable enough to hold the PV system. And I gave you, just for the fun of it, when you get a copy of the slide deck, if you need this, there's an example of how you can calculate that and use that formula based on the conditioned floor area and your those factors from the table. If you use a performance method, the software is going to calculate it for you already. And then once you have that information, if you're an architect or just needing, and you're not having your electrical engineer or your PV consultant on board yet, you need to have an idea of how much space that would cover. I put an example here of a panel that produces 470 watts, for example, and you could take a look at that nominal rating, and based on your nominal size requirement from the previous calculation, you can get an idea of how many panels you need. Take the dimension of the panel and then start to lay it out on the roof so you can have an idea of how much roof coverage you're looking at. And then similar idea for battery storage. If you have a PV system requirement, then you will have a battery storage requirement. And the battery storage is also based on those same occupancy types: grocery, high-rise multifamily, office, retail, school, warehouse, etc. And there's one factor for looking at capacity and another factor that you use for looking at your power or energy capacity and power capacity, is sometimes it's written. There are exceptions to these, both of these, if the battery size ends up being quite small, or if your PV system is less than 4 watts, 4,000 watts DC nominally, then you don't have to install these systems. For your batteries, There are a few exceptions. So for example, climate zone 1, no battery storage is required for the offices, schools, and the warehouses, for example. And if your installed PV system size is less than 15% of the size determined in that equation, you don't have to put in the battery. Here's an example. I put in a picture of a type of storage system we're starting to see in projects. This is just one brand. We're not brand specific, but what I want to point out is that some companies are starting to figure out that there is a great way to package up the size batteries and include controls that work with the grid, and they're using a lithium iron phosphate chemistry that's more safe than like what you might be used to hearing with the issues of batteries and fire. So these are available. And for example, you could have a small commercial system or multifamily that uses a pre-configured packaged battery storage system where it's integrated with the microgrid controller, et cetera. And we just had a multifamily project that was speccing one of these out to meet all their needs, and they're finding that it's a lot easier to deal with as one sort of craned in element, and as rather than linking up a bunch of other smaller batteries. This form will be required is for Title 24, the PV and the battery. It's an NRCC SABE. And once again, you can go to the Energy Code ACE tools and do the interview and get your prescriptive forms for the PV and the battery. And we've been doing these forms even if we're doing the performance modeling, because this way it just drills in more specifically to the requirements for those systems. And kind of as a background, when you're working with your energy consultant, some of the inputs we're going to be asking for on these battery systems. So whether we're getting it from the mechanical engineer or the architect via PV and battery consultant, otherwise we're going to put in placeholders, and then this information will be needed, but we're going to want to know battery charge and discharge efficiencies and the rate of charge and discharge, and whether or not the project is going to have certain controls, whether they're just basic or are they going to engage in time of use controls and part of the big picture grid stabilization that PG&E is doing, or if they're going to have it included with that is advanced demand response controls and meet those JA12 demand flexibilities. And then if you put in more battery or PV than is required prescriptively and you're doing the performance method, this is one way you could bump up that carbon source metric if you need it. And then
before we leave solar, Georgia, a question
yeah.
about the clearances and separation when putting solar panels above heat pumps and storage tanks. I know that for a storage tank, the clearance, I don't know if there are any clearances, but for the condensers specifically, do you have any code separation limits that have to happen? Probably vertically is what he's asking for.
Yeah, I don't know. I haven't seen, not code other than 5 feet away from things that can oh, I'm thinking of the condensing units and anything that's going to make lint and dust. You need that kind of separation. But mostly the separation that I'm aware of now is coming from the manufacturers, because when you look up those condensing units, if it's like a split system, there's like some only have like they can be measured in inches, and some want several feet over the top clear. And then there's also just the ability that if you inadvertently create an enclosed environment for some of those systems, they don't work as well. So I noticed like some brands will specifically give you all the clearances if you're trying to put them in like a mechanical well, for example. So they'll say, you know, this many feet to the right, this many feet to the left, this many inches behind the unit, this much on top of the unit, and then don't stack the units too close together where the cold air blows out of one, it straight into the back of the other one, you know. The PVs, yeah. I think it's mostly about maintenance and the ability to change filters if you've got that kind of a system or just to work on it.
Yeah, it's definitely a little puzzle. The driver of that is, like you said, it's the condenser, the manufacturer of that condenser and what their limits are. But our roof space is, you know, being taken up by how you know, lay out those condensers on the roof, the solar, skylights, if you're including them as part of your project. Um, and I do know that the lifespan of those condensers, you can create situations where the airflow is not good. And then of course, also if you're raising solar up higher on a roof, your structural is going to have a big say about that because now you're adding potential wind loads depending on how they're oriented, pitched, and how tall they are, stuff like that.
For the projects we've had, basically we got the mechanical systems laid out. They all needed their requirements. Fire access needed their requirements. We worked with structural, all the parts of the roof that are structurally sound. And then that's what's left for the Sarah. And we, you know, do the quick times 14 watts per square foot, compare it to what the performance calcs produced. And then we kind of go from there and just laid the PV out on the rest of the roof. We haven't done too many where they're up above it.
Yeah, George mentioned fire. You're totally right. There's a number of constraining items when designing these larger roofs with so much equipment and so many different setbacks. So it's definitely a puzzle that, depending on how many of those systems you're including and how ambitious you are on, you know, maximizing that system, it'll take a couple different disciplines to address each project specifically. Okay, go ahead, Jennifer.
Okay. And then real quick, just kind of big picture changes on the alterations. This, like I said, this is like a whole section in and of itself. And there's one that kind of impacts architects that stood out to me potentially is wall alterations. When 25% or more of the building envelope wall area is altered, needs to meet the air barrier design and material requirements for newly constructed buildings. It sounds a little more daunting, and then you take a look inside like the residential compliance manual or in the code, and then they'll list those materials that are acceptable, and it can be even as simple as taped and sealed drywall. If that's the air barrier for the building, you can do that and continue it for the rest of the building. But the thinking here is to start to get the architects to really think about a continuous air barrier in their whole project. And this is an opportunity to kind of apply that. And a great resource is to just go straight into the compliance manuals, because they have cost-effective considerations and details for those various things that deal with roofing, and then, or I mean, deal with the building in general. And then for roofing, big change, relatively speaking, on alterations, roof alterations. Just a reminder, you know, 50% or 2,000 square feet existing roof is replaced or recovered. Then the new requirements under section 140.3 are triggered. And the end result of the change is that there's just higher levels of roof insulation. But again, it's comes down to a detailing thing that if you're an architect and you're working with your client on this, then you got to be looking at what's going to happen with above deck roof insulation and potentially how does that interface with the rest of the project. And then last slide is just, again, a little bit reminder that the HVAC alterations, then those updates on HVAC system, duct alterations with duct leakage and water heating alterations, a lot of these have been kind of updated to mimic more what the requirements are in new construction. But when these things trigger, it's is just a little different. So, you know, if you're doing a duct alteration, for example, and new ducts, if you're replacing 75% of the duct system, that's considered new ducts. And then you're going to get to that 6% leakage, you know, being triggered on those systems, similar to what we saw under the prescriptive and the mandatory measures. Okay, and then a reminder, additions and alterations can be shown to comply both under the performance method and the prescriptive checklist method. And with that, I'm going to remind you about our Code Coach program. If you have any questions, you can reach out to us for the Code Coach. And I'm going to turn this back over to Sarah to give us a quick rundown on some upcoming courses. And then if there's any other questions, if Sarah has time, Grant and I would be happy to stay on the line and have any discussion or questions you want.
Yeah, thanks, Jennifer. So just in closing, there are AIA and ICC learning units available for the course today. And then you'll be getting a copy of the slides and a link to the recording sent to your email. We also have a survey that will be linked as well. And it always helps us out to get feedback and helps us determine new courses or just anything along those lines. We have our upcoming courses. This is just a snapshot of some of the upcoming courses. We have a lot more on our full catalog on our website, but I specifically wanted to call out the last one there. It's September 30th. It's a 5-day in-person passive design build bootcamp with Emu Passive, and it is at the People Self-Help Housing here in San Luis Obispo. I'm going to add a link to the flyer into the chat. So if you or someone you know are interested in learning more about passive design and want to have that hands-on training, this would be a great opportunity for you. And yeah, with that, we are at time. So if folks need to hop off, please feel free to do so. If you do have some questions, we can stay on for about a minute. But otherwise, we do have our Energy Code Coach service, so for any follow-up questions or other questions. Okay. Well, thank you all again for joining us, and hope you have a great rest of your day.
Thanks, everyone.
Thanks, everyone. Thank you.